Reactions of hydrocarbons, we were able to make alcohols by hydrating an alkene. So once you have that down, you basically have the first reaction of alcohols down because it's just going backwards now. So here's that hydrated, or the alkene. So if I want to add water to it, just as a review, you would be making an alcohol. So that's what we had in last video, and it turns out you can do so much with this molecule now. Alcohols can give you aldehydes, they can give you ketones. You can oxidize those further to get carboxylic acids, and if you have two alcohols, you could add those together to make your ethers. So I decided to just put all of that in one video. So we'll just work with this one molecule that we made there from the last video and do all of that with it. Pretend I had two of them. And I'll draw the other one down here on purpose because it'll show you this. Basically, for any of these other reactions besides the hydrocarbons, you're going to be deleting something from the molecule, and it's going to be like water. It's going to be like a small molecule. You're going to be deleting water, or right now I can't think of any other examples. And when you delete them, you just basically glue the other two pieces together. So for some reason, I'm writing it weird from right to left, but whatever. Here's the H2O that I've circled here that I would make. So then I just draw everything else minus that one bond. So this was the question mark because I deleted the OH from that one, and then I have an O with a lost hydrogen now on the second molecule, plus that H2O I made. So here is that bond that's going to form. This carbon only has 1, 2, 3 sticks, and it's like I need a fourth. This oxygen has one stick, but it needs that other one as well. So that's why that bond is going to make an ether with the C, single bond O, single bond C. And I can draw that way better over on this side. So from two alcohols, you delete a water and you make an ether. That would be it. Pretty easy. Once you have that down, go back to that original alcohol, and it's even nicer. You can make, let's do aldehyde then. So when you have that original alcohol, and add an oxidizing agent to it. So right now for you guys, that's just a square bracket O, but it's actually a real molecule. And an example of that is potassium permanganate, KMNO4. So that's why it has those oxygen atoms to make more oxygen bonds between the oxygen atom and carbon. That's all you want to do. So when you have alcohol, to do that, you're going to have to make a double bond to that alcohol. And instead, it becomes an aldehyde now. This was a primary alcohol because my carbon that had the hydroxyl is only bonded to one other carbon. So when I make a primary alcohol oxidized, I always make an aldehyde because it'll be at the end of the chain because that's a H and a H there. But putting those side by side, if I were to do a secondary alcohol, where now the carbon that had the hydroxyl group bonded to it is bonded to 1, 2 carbons, and I tried to oxidize that one, now my double bond would be in the middle of the chain. And that makes this one a ketone. And the small molecule that you're going to be making from both of these reactions is plus H2. I think somewhere in the answers I've put plus H2O somewhere, and that was just definitely a typo. It's only plus H2 that you make. So then I did something really weird on the board where I made it a tertiary alcohol. And let me show you why that one has no reaction. So the carbon that has the OH bonded to it has to be bonded to 3 other carbons to make it my tertiary alcohol. And when I trioxidize that, this is what I would hope to get, a double bond O again. But if I look at that carbon, it has 1, 2, 3, 4, 5 bonds around it, so that'll never happen. Carbon only wants to have 4 bonds around it, and that's why this one is just a no reaction. So alcohols can be used to make ethers. It can be oxidized to make aldehydes or ketones. And you can go backwards, like I was saying before, to do the reverse of the hydrocarbon reaction and make an alkene. And that'll be the last reaction. And that example, I find it's harder to see sometimes because you don't really have any reactants. It's just this. Whoops. It's just an alcohol on its own, and then it'll be something like an acid and heat I'll give you. And you have to recognize that it's going to make the double bond. It's the backwards of the hydrating an alkene. So you're going to make the cyclic molecule and plus your H2O. So that's the HO and an H, right? So the OH that got deleted was this one here. And your choice is to delete this H or this H with it to make the water. And honestly, it doesn't matter, whichever one you want to choose. So now that carbon lacks a bond and that carbon lacks a bond because it just has 1, 2, 1, 2, and I guess there's secret H's there. This one used to have 2 H's. So what needs to happen is the double bond to fulfill the 4 bonding capacity. And that's why you get the alkene back. That's the final answer. And that's all the reactions for alcohols, ethers, ketones, and aldehydes.